Hello there, everyone. I'm Daniel Huffman, and this is my beautiful hair, and we're here to do some live Carto. Thanks for joining me on this, well, at least in my time zone, this part of the world. It's Friday afternoon, so I'm wrapping up my week doing this, and looking back, this is the 16th time I've done something like this over the past, 3 years, 4 years, something like this. And as usual, I'm going to try and do something that's a little different than most of the other times I've done something like this. And I've done project breakdowns. I've had people just kind of watch along while I kind of do my work and label maps and things like that. I've given sort of mini lectures and how-tos about labeling or particular tasks in Illustrator. But today I'm just going to talk a few odds and ends that tie into my love of map projections. I love thinking about projections, and I think they're somewhat underappreciated in terms of their value in the aesthetics of a map. Because when we talk about map design, oftentimes, tutorials and classes and things like that, they'll talk about choosing a good typeface, choosing some colors or line weights or proportional symbol styles or whatever. And these are the kinds of things I talk about on my blog and you've seen in lots of other places probably. But projections also have a pretty significant impact on the aesthetics of your map and on the mood it can manage. And, before we have to choose our colors, before we have to choose our typography, we have to choose what shape is the land going to be. And in maps that are very small scale, where we're zoomed out and showing the whole world or a large chunk of it, that kind of thing can matter a lot. So as a side note, for example, this is a map that I showed. This is a map that I showed, I think, last stream when I was talking about. I kind of went through what kinds of projects I work on in the last year or so, and I might have showed this thing. And this is about human migrations across the Bering Land Bridge back when that thing used to exist. And I have an orthographic projection, sort of looking down at a globe, because that creates a very dramatic effect. So these kind of things, I think are worthy of some consideration. Projections aren't this thing that you have to do. You can kind of make some active choices toward it. And I'm not going to get into, some of the things that you might see in an ordinary class about projections. That's the kind of thing I've taught before. I've got like 2 or 3 hours of lecture material on projections about, equal area and conformal and conics and cylinders and aspects and things about why you might pick each of those items. But that's kind of the kind of thing that gets covered in a lot of other places. And so I want to take us a little bit more off the beaten path. So what I'm going to talk about today will hopefully be interesting, but it may not be as directly useful as pondering, the aesthetics of this projection or that one. But I just wanted to kind of make that as an aside. What I want to do primarily is show off a piece of software. And this is really the reason why I kind of gave this live stream, is that I recently rediscovered a program that I used to mess around with some years ago. And I got excited enough about it that I wanted to share it all with you. And from there, we'll spin off into a few other interesting things. And that piece of software is called Geocart. And you can find it at mapthematics.com. It's not very well known. There might be a few of you watching this who've used it before, but it flies under the radar for some reason that may become apparent later on. But I think it's pretty cool and pretty useful. And the main thing that Geocart does, right here, if map projection is your problem, then Geocart is your solution. Geocart is map projection software. So you can kind of think of it like a very limited GIS. If you open ArcMap, you open QGIS or something like that, you can load in some data, you can give it a projection, fine-tune your projection, and then you could do some other things, maybe some various analysis of your geometries, some styling, things like that, to finalize your map or prepare it to export to other programs where you'll finalize your map. Geocart doesn't do most of those things. Geocart lets you load data in and then project it. But it does that a lot better than basically any other program. And for me, I played around with it because of some of its novelty aspects that we're going to get into in a little bit. But what I've recently realized is that it may have some value to me in my cartographic production processes. Because, I use QGIS a lot. So, for example, maybe I'm working on a world map and here I've got some natural Earth data loaded in. Just 110 million scale, very simplified. And I say to myself, well, I need to reproject this for whatever map that I'm making. But some of you, if you've used QGIS or maybe some other some other GIS programs that are doing projections, you may notice sometimes when you're working with projections that things get a little weird. Things get a little erroneous and full of artifacts. So if I shift around here and I say, convert this over to a Lambert conformal conic, and this is one that happens to have parameters that are fine-tuned for Europe. If you dug around here, you'd see the standard parallels are, standard parallel 1 is 43 degrees, parallel 2 is 62. So that conic has been fine-tuned for the area of interest. And that's something I always do for all my projections. It was kind of drilled into me as a student, like every time you pick a projection, choose the right parameters to focus and minimize distortion on your area of interest. But if I choose this, then QGIS gives me something like that, which doesn't look right. I can kind of see my land shapes are pretty well there, but, over here, that's kind of weird what's going on there. Some things are kind of stretched out. And then if I zoom out, the whole world seems to be bathed in this orange light because if you follow this coastline, this is actually the coastline of Antarctica, and this part here to the left should be the land, not the part to the right. It just got inverted because part of these coordinates went off into infinity. So maybe you've experienced these kind of things in some GIS programs before, and that's because the math of projections can be really hard, and implementing that programmatically can be a challenge to get right. So I'm not blaming the people who make this program. It's difficult, and I've talked to colleagues who've worked on these kind of things before. It's not easy, especially when oftentimes we're loading in a data set that looks like this. This is how natural Earth data is stored. It's stored in a Plate-Carré projection in geographic coordinates, and the world is round, and yet we have to show a left side of the world and a right side of the world, even though this part of Russia on the right touches the part on the left. So we have to interpret that mathematically and make sure it all wraps around correctly. So that's where these artifacts come in. And a lot of programs struggle with that. In my experience, Esri products don't, and I give them, credit where it's due. I think they do a pretty good job of generally handling a lot of projection stuff without most of these issues. I very rarely run into anything there. Whereas some of the less expensive or open source software can struggle with that because it's open source and it takes a lot of work, so people are not being paid to put in the work to get that done. I understand. And so what I might start turning to myself, now that I've realized, now that I've sort of rediscovered this program, is I might start turning to Geocart to solve some of these problems for me because, as they said, if map projection is your problem, Geocart is your solution, and it does this better than anybody. So let's dive right into it. Well, actually, before we start, one thing I'll notice, I'll point out to you, Geocart does cost money, but it turns out that there's a free demo version, which is actually, it's really, you just download the whole program, and you can buy a key to unlock certain features that are already in the program. But it turns out the demo version isn't limited. The limitations to the demo version are not problematic for the kinds of things that I want to use it for and for the kinds of things you might want to use it for. Because you can reproject vector data and play around with it all you want in external software and not run into the limitations. But I already have Geocart downloaded. It's pretty easy to grab. It runs on Mac, runs on Windows. Don't know about Linux, doesn't say there, so probably not. But I already got it on my system, so I'm just going to go Geocart and ask me, hey, do you have a key? I don't. I'm going to run it as a demo. I'm used to running this program, where I first discovered it is at the University of Wisconsin Cartography Lab, where they do have a key to it, so I first started playing around with it there, and I thought, well, probably never use it at home because it's not worth it for me to pay for, but now that I realize I can actually do some things with the demo version, now I just downloaded it at home. So I've started the program, but you notice nothing looks different. I still see my web browser window here in the background, but on the top here, you see it says Geocart, and it's got some Geocart related menus. The program starts up and doesn't show you basically anything. The user interface is not the most modern or up-to-date. That's not been the priority in creating this software. And this is put together by somebody, this is his side project. Dan Strebe, he's involved in the NASA's community. I've seen him at conferences there, and we've had some nice chats. And he is, in my impression, and I'm not an expert myself, my impression is he's probably one of the sort of main go-to projection experts in cartography. There's a handful of people who really get it. I like projections, I like messing around with them, but I'm not a mathematician, and if you really dig in, projections involve a lot of complex math. I don't get any of that stuff. I don't know. People like Dan Strebe do understand that, and that's why he was able to write a program like this. So, this is just a side project for him he's been working on for a couple of decades. So sometimes the interface can be a little clunky, so I'll take you through, though, in case you're ever interested in trying this out yourself. I'm going to go to New File. That's my first thing. And it pops up a little window for me, so I can actually start to see what's going on. And this is a document view. This is like your virtual piece of paper. This is the same thing as if you were in ArcMap and we're going to the layout editor, or we're in QGIS and we're going to the print composer. It's the same thing. It's a page that you can put a map or multiple maps onto. So I've got my blank page, and I can go to my document layout if I wanted to change my dimensions. I'm fine with how it is for what we need to do here. Next thing I'm going to do, though, is I'm going to go to New Map. I'm going to put a map on this page. And by default, it starts me out with a sinusoidal projection and in a sort of small map in the corner. So a couple of things. I can zoom in. I got a little zoom tool here. These are the 4 tools that exist. So I could zoom in. I could also use keyboard shortcuts of Control minus and plus, Control plus and minus to zoom in and out. I've already lost where I am on the page. Better use the hand tool. Oh, I deleted it. How did I do that? I must have hit the delete button by accident. Okay. See, this is live tech demos, and I promise you I mostly did not prepare for this demo at all, so you can experience it the real way, not the cleaned up way that sometimes tech demos go. I'm just going to fumble around in the software because I only recently rediscovered it, so I'm not super familiar with all the details anymore. So we've got our sinusoidal map here. I can, if I want to make it bigger, I can go to the map menu where I created a new one. I can say map size and resolution. I can say how big I want it to be. And the resolution is for if we're dealing with rasters. In this case, it actually by default loads in a raster map of the world, a little sort of some satellite imagery on the land and blue water. So I could retune that, and I could say, let's make this thing 400 millimeters wide on my page. And it gets a little bit bigger. I could also, when I do that, I'm changing the scale of the map. Right? The scale is about the relationship here between the map size and the page and the reality of the Earth. So instead of changing the map size and specifying it, I want it to be X inches or millimeters wide, I could also say, let's change our nominal scale. We could make this a 1 to, 100 million map. Is that 1, 2, 3, 1? Yeah. No, 100, 1, 2, 3, 1, 2, 3, there, 100 million, okay. Which is pretty similar to the size we already had, but it would shrink or grow the map accordingly to the scale you wanted it at. So that's real basic. Now let's look at changing projection, because now we're going to start to get into some of the things that Geocart does that other things don't do as much or as well. I said before, for example, ArcMap doesn't really, ArcPro and such Esri products don't generally have a problem with projections, so why would you use this if they don't have the artifacts? The thing that Geocart offers that nothing else really does, besides getting all the math right and not having artifacts, is that it has a huge library of projections, many more than you'll find anywhere else that I'm aware of. I've looked through the library, Proj 4 library, or, Arc's list of projections, etc. None of them are nearly as extensive as this. And so if there's something obscure you're looking for, I should say, I went projection, change projection, going to that menu, then Geocart is an interesting option. So right now it shows me I've picked a sinusoidal, and it's got a little info box telling me a little bit about it. It's the sinusoidal. It's also got a couple other names. Geocart tends to list projections under several names just in case you happen to know one and not the other. So apparently the sinusoidal is also called the Sanson-Flamsteed. And then it's got some details here. It's a pseudocylindric projection. It's equal area, describing the graticule, the aspects, the distortion patterns, what it's commonly used for, other projections that look like it, when was it developed, who created it and why, and a distortion diagram here on top. That's a really cool feature that Geocart can apply to any projection. It'll tell you, what areas are more or less distorted, and that's one of maybe the basic things you've learned about projections in the past, if you've delved into this subject at all, is that, projections, we have to distort the world to project it, to make it flat, but those distortions are generally not even throughout the whole map. There are different kinds of distortions, of area, of angles, of distances, and then there are different quantities of distortion. So this sinusoidal is equal area. It doesn't distort areas. All the sizes of all the continents are in correct proportion to what they'd be on the Earth, but it does distort other stuff. But those distortions are very minimal along the middle, along the equator, and along the central meridian of our projection. Then they get worse and worse as you could go away from there. And that's what this diagram is showing. And it has these for all the projections. If I pick a Movida projection, you can see that there's a couple little dots on this projection. Little areas a little north and a little south of the equator in the middle. Those are the areas of minimal distortion. And the distortion pattern kind of follows waves as you get toward the top. So even if you never use Geocart, this itself is kind of a valuable educational tool to understand the distortion patterns in projections. And you don't actually have to have Geocart to look at this data set. If you go to the Map Thematics webpage where they have Geocart, you can click on projections, and they've got this whole same setup. The list of all the projections in the software and the same pieces of information that you can find in that program. So, if I go down to sinusoidal, right, it's the same things we saw. So, at the very least, maybe familiarize yourself with this webpage. It's pretty cool. It's got a lot of stuff in there that I find fascinating. So back to Geocart, though. I can pick any projection. I can say, let's go with a Bromley. That sounds great. And it reprojects for me. All the projections are also available from these menus up here, where they're sorted into classes. Perhaps you've heard of cylindric projections and conics, pseudo-cylindrics, azimuthals, and Dan has created a class called lenticular, and everything else that doesn't fit any of those is miscellaneous. And again, these are all the same things that are here. They're just subdivided in these menus into just some groupings. If you kind of know what you're looking for, that's, if you start to get your head around what these classes mean and how things look, that's kind of useful. So that's kind of the first potential advantage of Geocart, is that it offers you a lot of projections maybe you can't easily access. I was talking to somebody recently who was interested in doing something in the Boggs-eumorphic projection, which you can't get in ArcMap, and it exists in the Proj 4 library, but Google doesn't, the transformations are not implemented in there, so you can't get it necessarily through QGIS, but it's in here, the Boggs-eumorphic. It's sort of a less popular alternative to the good Homala sign. And we'll talk why this is different in a minute. Why this looks, why is this shape when it looked like this shape over here? we'll get to that in a little bit. Oh, good, my first chat message. By the way, yeah, if you're here, say hello. So I'm not shouting at, an empty void. I'm happy to help Brandon. I'm happy to introduce Geocart to other people. I love it, even if it's just to play around with, even if I don't use it for practical purposes. Projections are fun, and Geocart makes them fun. The thing I'll mention too is that it's got this big thing that says demo slapped on top. Again, I'm just using the demo version. And if the limitation that you're going to run into is if you don't pay for it, and you're working with raster data like this data set here, then that word demo is going to be, that watermark is going to be burned into your image. But if you're working with vector data, later on, if you open this stuff up in something like Illustrator or Inkscape or other vector editing program, you can take away the part that says demo and just have your vectors and mess around with them. So that's why I'm potentially going to be able to start using this for my own work occasionally if I'm using QGIS and something is broken and I really need a certain projection. So let's take a side trip and talk a little bit about how to get your own data in here. Because right now it's just got this default image that it's loading in, and I would perhaps like to load in something of my own. Like a GIS, I can load my own data in here. And the way we do that is we look at the map databases. Again, the terminology is a little different than most other programs would refer to it. It can be a little bit different than you're used to. But the particular data sets we've loaded in are called databases in this case. So it says the databases to draw on the map are the stylized world topo, 5400 by 2700 pixels. That's just something that comes with Geocart, automatically loads in. I can remove it. And I can instead add any database, or a user database, which I think is basically the same thing. These three buttons, if I recall, are mostly... Yeah, see, this takes you to browse your hard drive for data. This one also takes you to browse your hard drive for data. This one also takes you to browse your hard drive for data. Not exactly sure why there's three buttons. But anyway, I can, look here and I can look at my natural Earth data, and I can say, find some 110 million scale land. Let's find the land. Yeah. So I can load in shapefiles. You can also load in, for raster data, you can load in TIFFs. I'm not sure what the other... Let's see, it says TIFF, JPEG, and Photoshop image files can be added as global coverage raster databases in geographic projection. I'm not sure about the vector data, if shapefiles all, or if it takes other things. Never really tried. But at least in common formats, things like TIFFs and shapefiles, you can pull that in. So I've got the Natural Earth 110M land. So, and I removed the raster data, so I hit OK, and now that's pulled in. Now I can see that. And by default, if I zoom in here a little bit, it's also simplifying my vectors down just a little bit. It automatically has vector generalization. I can change the level of that, or I can just turn it off. If I turn it to none, things got a little bit more detailed. So it's got a little bit of simplification capability, like you might find in GIS. But for the most part, it's just going to draw these things in. If I now want to mess around with some projections, let's start to look at some of the weird and fun things we can do with this. So let's say I'm going to do a Lambert azimuthal equal area projection. Okay, that's something that you can get in ArcMap, you can get in QGIS, etc. Now, you may have moved around, you may have used one of those and moved around before and changed where the center of the projection is. We can do that here by going to change the projection center. We've got a little menu here. I can click around the globe and say, or I can type in numbers up here and say, let's center that, on Madagascar. That's 20 south, 47 east. And it does that. That's not unusual. But we can do that for projections where ordinarily you might not. where you can't do that in a lot of GIS programs. So for example, if I pick an equal Earth projection, right, that's a pretty popular projection nowadays, been kind of trendy the last few years, and it's a great projection, looks good, fits well on the page. This is how we're used to seeing equal Earth. And if you open it up in other GIS programs, the best you might be able to do is shift the central meridian around, right? Whether or not we move, whether or not, for example, we move things just over to the left and right a little bit, which I can do here. I can say, move it 30 degrees over. That's not unusual. But here's the thing about the mathematics behind projections. Those mathematics describe how to take a round thing, almost a sphere, and then unwrap it into a shape like equal Earth or any other projection. It doesn't say that your globe has to be upright. The math works the same if you rotate your globe. So for example, if I instead say rotate my globe like this, and then unwrap it into equal Earth, then I get this projection. Now that's just cool. That's fun. I mean, this is probably not something you necessarily need to make a map of, but I think it's pretty fun. And I think novelties like this are not only interesting because they are unusual, because I'm the sort of person who likes playing with projections, but I think it's a valuable educational tool, either for a classroom or just for ourselves, or for a mass audience, because this projection is equally legitimate to maybe a more familiar presentation of the equal Earth. Let me put another one below it. Make a new map here. I'm just gonna set this up real quick to be another equal Earth. I'm going to deactivate. I'm going to remove that. And instead of adding any database, I'm just going to add recent one, and says it pulls up the menu of ones you've done recently. I'm going to say, put in an equal Earth again, and make this, 350 wide or something like that. Right? It's the same math. It's the same projection. It's the same distortion pattern. It's just that we've rotated the Earth a little bit beforehand. And I think that's fascinating to realize that it's the same planet, and it's just two different perspectives on it. And one of them is unfamiliar, but that's kind of arbitrary. That's kind of conventional. Maybe you've seen, for example, those maps that they sell. People sell wall maps that have the Earth upside down, right, where south is pointing toward the top, and Australia, New Zealand, and Antarctica are on top. And those maps are novelties, but they're also made to point out that, well, north is a societal construct. It's just a way that we're used to looking at things. It's no more or less legitimate way of holding the Earth and making it into a map. So that's where I think these things are not just for fun. They kind of teach us something. They remind us of relationships that aren't apparent, that we can see, for example, just how close South America is to Antarctica in a way that, Antarctica looks stretched out here. Parts of Antarctica look far away from South America when all parts of Antarctica are not terribly far from the tip of South America. Things like that. And they also make the distortions, I think, more apparent. We might be used to seeing a projection like equal Earth down here, and we're just used to seeing Greenland squished up at the top, for example. But we might not be used to seeing, or Antarctica squished at the bottom of a lot of projections, but we're not used to seeing Australia squished and stretched out, and it reminds us of what that distortion is, that whatever's at the bottom is not being shown correctly. It's being warped heavily. But again, between these two, the distortion pattern doesn't change. And we can look at what that pattern is. If I just look here, get a little diagram. And again, I see whatever is kind of a little bit north of the equator, about halfway up and halfway south of the equator in the middle. Those are really good. Those are minimally distorted. As we get farther away from those spots, things get worse. And that's what we see here. The pattern of distortion holds. So that's kind of one fun thing we can do. We can take any projection in Geocart, and we can change what we call its aspect. basically the angle at which we're holding the globe before it projected. Or another way to conceive of it, if you understand this kind of model of projections, is we'd be rotating the developable surface around against the globe. And really the only time we ever do that outside of something like Geocart in a common situation is if we were working with Mercator projection. I'm just gonna shrink this here just a little bit. No, I accidentally made it twice as big. I gotta remember how numbers work in map scale. There we go. We have a Mercator like this, but perhaps you've heard of the universal transverse Mercator. And a transverse means that we would be flipping the Earth over on its side, like this, and then doing the projection and holding some strip of it. Or occasionally we'll do oblique Mercators. So my home state of Michigan, their coordinate system is an oblique Mercator, where it's just at some other weird angle. But that's really, the Mercator's kind of the only one where we do that regularly. But with Geocart, we can kind of do that for anything. So I can flip this to wherever we want, and then change the projection even, and it'll say, well, let's do, the Winkle triple. That's a popular one too. And we can do the same thing there. Different set of math, different set of distortions, but we still kept the globe tilted at a funny angle. So that's one thing to play around with. Now, I promised I'd tell you about when we did that Boggs eumorphic. Said one of the things that's weird is that it doesn't look the same between what we've got here and what we've got up here. So the reason for that is that interruptions are sort of, these divisions here in the projection are things we add to the projection. You can take a projection and you can add slits in it to reduce distortions. But you can do that to any projection, or, okay, not any projection, but you can do that to a lot of projections where we don't ordinarily do that. And that's something else that's very interesting about Geocart. So if I reset this thing back to its center, if you notice here, I've set it back to its default, and it's got these slits in it. And those slits have the effect of making it so that these areas are not as distorted as they would be if there were no slits. It's kind of a trade-off. The interruptions themselves are serious distortions, right? We're taking things that, this part of Greenland is next to this part of Greenland over here in reality, but we made them look really far apart. So that's a severe distortion. But the trade-off is now the rest of the distortions aren't so bad inside, next to those areas. And we can look at some diagrams later about that. But really, mathematically, the way the projection's kind of working is it's really just saying, well, let's run the projection over here and then stop it, and then go start the projection from scratch over here and run it again for a little while. And that's kind of how it's working. So we can take any projection and kind of do a little bit of it, interrupt it, do a little bit more. So if I go to, I gotta select my map. That's what the pink is, I've selected it. So if I pick a projection, like a Robinson projection, another really common world map projection, I can interrupt this thing in the interruptions menu for the projection. I can say, well, put the same interruptions that you would have in a Boggs projection. Put them in the same spots. And now I have an interrupted Robinson projection. It, again, it just runs the math for the Robinson projection. It just runs it in a couple of different batches in different spots and puts gaps in between. And with the corresponding effect that it reduces some distortions because of that. So I can do this with a lot of different projections, primarily ones that are pseudo-cylindrical or lenticular. If you try and do it on certain ones that it doesn't make sense for, you'll get an error, say, oh, the map is too big, or there's different other things that, things go out to infinity, or certain bits of math crash, and they'll say, path not contiguous. So it'll just warn you in an error that you can't divide that. But you can usually divide any of those projections that have these sort of broadly that are kind of oblong and have some sort of rounded side. That's generally the case in which you can do this. So almost all those projections would fit under lenticular or pseudocylindric, and we don't need to get into what those classes mean, but in a menu like this, if I was going to change projection, that's where I'd look, pseudocylindric. Now, one other useful thing from an educational perspective for yourself or for classrooms, again, I said, that we have these diagrams here about the different kinds of distortions that we face. I can get it to do those live and in response to particular changes that I make to the projection. So if I pick the sinusoidal projection where we kind of started things, I can say map, let's see, distortion visualization. I can turn on a distortion visualizer. So it's going to replace all my line work or raster or whatever I've loaded in with that kind of diagram we saw before, and I can tell it, well, what kind of distortion do you care about? Angular, scale factor, logarithmic area, finite scale for area, how many gradations of color. Right, there's a lot of different options here, and I would have to stop and think really hard about what some of them are and what some of them mean. And again, we don't need to go into detail here, but I want to show you this option exists. I know this is an equal area projection, so let's show angular distortion. It does show the vectors on top. I didn't realize that. Or maybe that's a change in the program. So it's showing me much like that diagram that we saw before. Right? This thing. But it also lets me see how, if I were to interrupt this projection, how that affects the distortions. The distortion pattern is much better because the vertical middle of our projection, the central meridian, as we would call it, if I turn off the interruptions, that's an area of very low distortion. So interrupting our projection, let us have more of those little central meridians that we were starting over from to minimize distortions. So this is a nice thing that I use to show students about why we would add interruptions to a map. So it's kind of fun to play around with that. And perhaps you're more familiar instead with Tissot's indicatrices. That's another more common form of distortion visualization, and you can turn those on here as well if you want. On the other hand, if I turn the distortion visualization to show me aerial distortion, we don't see anything because there's none. This is an equal area projection. All right, so I'm going to turn off that. The other thing, excuse me, water here. I have been rambling on. The other thing that we might want to play around with here, a couple other options before we move on to how you get stuff out of Geocart. We can adjust our graticule options. We can say how often we want them to happen. And we can also do pruning. We can say pruning out. We can say, if these things start to get too close to each other, maybe start to turn some of them off. So I'm going to turn off the indicatrices. But if we zoom in, you can see here, you can see the graticule lines, the meridians, the lines of longitude, thin out as we get toward the top. Because in a lot of projections, they just cram together and look terrible. So you can turn on options to automatically say, if they start to get too close together, don't do them as often. That's a graticule option, as well as just picking how often you want it. The last thing I'll point out is something that you probably don't need to mess with too much if you're planning on exporting your data, but I can play around with line styles. This is where I can change the colors of our lines, and this interface is a little confusing to me, and again, I haven't used it in a while, so I'm going to work my way through it. Let's see. Map boundary, right? That's the outside of our map, and I could say change the stroke color to, I don't know, make it red. That sounds great. Or I could specify RGB numbers or transparency, and I could say the width or a dash pattern. I'm not sure what how one specifies that. I'd have to check the manual, what you have to type in there to specify that. But if I hit OK, yeah, changed that. It changed my outer boundary. Line styles. Let me go back to that. There are also things like inherited line styles. Here's what the graticule looks like. It's gray, but it's partly transparent. And meridians use the parent's attributes. So it's got this hierarchical line style thing where you can define something to say, normal graticule inherits the meridian style, which inherits the graticule style. But if it's the prime meridian, use a different style. And if you'll notice, the prime meridian is darker. So you can specify this hierarchically, and I'm not really going to get too much into that. My shapefile is called my coverage. And this says coverage ocean coast. I loaded in a file that was natural Earth 110 million land. But it didn't call it that because this is a recent enough program, it knows natural Earth. And so it renames your shapefile and calls it a coastline. It knows that's what it was that you loaded in. So finding what you loaded in there, you might have to play around a little bit because it might appear under a different name. And again, I can say, let's, instead of using the parent attributes, define something new, make it, I don't know, green. That sounds great. And there we are. Green. Looks terrible. Can't see it. But that's all set for me because now that's all I need. I'm going to kick this out to Illustrator. One other thing I'll mention. You can't put a fill on your shapefiles. You can only do strokes in Geocart. Not sure why that specifically is, but I can't fill in the land color here. If I go back to the line styles, it's just lines. What is my stroke color? If I want anything else, well, that's too bad. I'm gonna make this dark purple. Yeah, that's better. This is what I've got. But again, for my purposes, I'm gonna send this to another program. And so it doesn't matter so much to me. But this is definitely not a program in which you're likely to be able to style a finalized map the way you could potentially do exclusively in GIS. So if you're working that kind of style, then Geocart's probably not for you beyond playing around with for fun. But for me, this will work. So I'm going to take my let's pick a different projection here. Something a little unusual. Oh, the times projection interrupted. Yeah, that looks terrible. Great, let's do that. I can export a document. That's how I get things out. And this pretty much just exports to graphics programs. It's not going to export like a georeferenced something or other that you can load in ArcMap. Again, ArcMap doesn't handle some of these coordinate systems, some of these projections. It wouldn't know what to do with it. I can export rasters, TIFFs, JPEGs, Photoshop files, or I can export vectors and rasters potentially as a PDF. And that's what I'm going to do here. So I'm just going to export this untitled PDF. And that was the thing I was showing you before. And I'm going to pull this up in Illustrator. All right, let's shrink this Illustrator window down to fit what you can see. Okay, so here we are. I've got my PDF opened up, and this is going to be a little annoying in the way that perhaps if some of you are familiar with the challenges of getting a document into Illustrator, or this would be likewise Inkscape or other vector editing programs. Getting out of GIS and into those programs involves some disassembling and cleaning up of files. Geocart is no different. I can look at my layers here, and everything is in at least nicely in groups. there is a group that has the demo watermark on it that I can just delete. And then I've got one for my land, one for my graticule, and one for my boundary. So I'm just going to quick make new layers for each of those ones. Graticule, boundary, and land. I'm going to select everything and release those clipping masks and get rid of them. Now I could pretty much do whatever I want with this map. There is one significant downside though that's worth noting, which I recently discovered because I had never really tried to do this before. I'd always just played with Geocart for fun and not really kick things over much to Illustrator. These things do not always come out as whole shapes. So, for example, I clicked on Africa. Here, let me make my highlight color something you can see a little bit more clearly. Okay, so I clicked on Africa here to select it. And you can see it stops right there. This over here, this part of Eurasia, Africa, that whole landmass, is a separate shape. So if I wanted to try and fill all these in, select them and say give them a fill color, you start to get weird stuff like that. So that's a downside. You'd have to do some cleanup to make sure that, if you wanted to fill in land, that everything is correct. Everything is joined into shapes. You could use the shape builder for that, potentially in Illustrator, the miracle tool that I love so much. So I could say, for example, I tried this the other day with one. It seemed to work pretty well. I could say I'm making a copy of my land here, of my boundary rather. Let's make a copy of my boundary and a copy of my land, just so I'm not affecting the original ones, and go to my shape builder tool over here, Shift M, and see if I click on the shape builder. Let me pick a fill color, green. Now I've just filled in all my ocean as one shape. So I have also thereby made the land, right, as the opposite of that. So that's kind of fun. And if I really wanted, I can, I would have needed to manually click and fill in the Caspian Sea. You might have to tidy up a couple other things, but now this is all one polygon, which is great. And if I wanted, I could say, copy my boundary once more. I could say, take my boundary, join it all. The boundary is not even one shape. Wow, that's a whole bunch of separate paths. Hold on. This is all a bunch of separate paths. So I gotta fill that in with the shape builder into one solid shape. And then I can do the fill on that. And then I can say, bring this up, take this thing, and go to the Pathfinder tools. Oh, they're already here. They're off the screen. And minus front. So I took the boundary shape and subtracted the oceans, and now I have my land. So you could do some cleanup like that. The problem I noticed one time, this is only the second time I've done it, but the problem I've noticed one time in the past is that closing these shapes up, and this is true anytime you're in Shape Builder. Let me undo this, go back to where I was. Let's say, if I look at the outline mode, let's say this bit of land was a little bit away from the boundary. And it didn't quite match up, just a little bit off. So you'd hardly notice it if you zoomed out. Now when I try and do that, it fills in, I just pointed at the screen with my hand, like you can see what I'm pointing at. It fills in this little portion of Antarctica down here, unfortunately, because if you imagine this like flooding, a flood fill with paint, it flowed past that little gap in there. So sometimes you got to tidy up those little gaps to make sure they don't exist. That happened one time of the 2 times I tried doing this, so I don't know if it happens frequently, if that was rare or not. Is that a pain to deal with? Yes. And that's a challenge of using Geocart. But is it more of a pain than dealing with some of the cleanup that might be required if, depending on the kinds of errors, and there are worse errors that you can get in QGIS than this one for projections, it might be worth it to go to Geocart and say, well, it's going to come out clean. I have to do a little tidying up, but it's going to be fine. Versus sometimes this is unsalvageable depending on how bad it gets in QGIS. So it might not be ideal, but it's a better option than what you might have in your own GIS program. So that's why I might start using Geocart in certain limited circumstances in the future. So yeah, I'm ready to do whatever I want to do in Illustrator with this. So looking over the chat, the vector is not being completely reliably, might be the reason why there isn't any fill styling. I didn't actually think of that too. I was pondering this the other day. I thought, that's a lot harder to do. You got a line that's very defined. You can say, well, the end of this line needs to go to this coordinate in the projection. Whereas deciding what's inside and what's outside, that gets trickier because a fill needs to know that. And that's where one of the places QGIS is falling down. It got the inside and the outside of Antarctica wrong. So maybe that is a reason why they just didn't take that on. But it's not too big of a limitation. I'll show you one other fun thing about Geocart, then I'll move on to a couple other odds and ends that I wanted to mention today as part of our general projection fun time. Boundaries. Map boundaries. So one thing I can do is I can say, hey, don't project the whole world. Just do part of it. So if I say, just draw a little box and say, just do that. Just do, let me draw this again. And I can specify the numbers down at the bottom if I wanted to. Do North America and Greenland. And now it confines my projection there. This is not, the most, this is not necessarily something that you need Geocart to do because, if I were in QGIS or ArcMap and I would say, well, I could load in this and I could say, well, I'm not mapping South America, I'm just mapping Europe, so I don't need to delete that from my map. I can just zoom in to the point where South America isn't visible and I just won't show that on my map. But this boundary limitation does allow you to do some fun things. So if I reset this back to base and pick, for example, a Lambert-Azimuthal equal area. So if you've ever seen one of those double hemisphere maps, I'm going to interrupt this hemispherically. And didn't do it right. Let me do this a different way. If you've ever seen one of those sort of Renaissance maps where there's two circles, each one shows a hemisphere of the Earth, the way they're usually done is that instead of showing, instead of taking this projection, this runs all the way out 180 degrees from its center point, covers the whole planet. Instead, what we could do, though, is say, confine this to show only half the planet. I could say, draw a small circle centered at 0, 0 that has a radius of 90 degrees, which is a hemisphere. Now we only have half the planet. And then if I take this projection, rotate the whole planet around, so we're looking at the backside, and imagine that I've loaded in the same database here. And do the same thing, 0, 180, 90 degrees. This is a bit of a whirlwind, but I just want to show you this concept real quick. And we don't have to, go into, you can mess around with the details yourself, but right now we have two hemispheres of the world because each time we just clipped it down to half. The real fun thing, though, is what if I took this projection that is normally, reset projection, that's what I meant to click, and that normally shows the whole planet, and cut out the middle. I could say, cut out the part that is at 90 degrees north, 0 degrees longitude, go antipodal, sorry. Show only the part that is from the South Pole up to the equator. Now I have just the outer ring, which is kind of fun. I haven't found a specific use for that. Maybe there isn't one, but again, it gets us to think about projections. It gets us to think about what they're doing. And so this is, again, where it's useful for us to pause, or maybe use this to show an audience and get them to think, again, this is a legitimate projection. I could have two of these side by side, two rings, each one showing a hemisphere. It is distorted, it is unfamiliar, but the spatial relationships remain the same as in any other projection. And that's kind of mind-blowing to think about. It breaks us out of the familiar perspective. So that's kind of the fun thing I wanted to point out there with the boundaries. And I messed around with this not long ago. I put a thing on Twitter. Let me poke around and find where that is. Where I took a projection and I made a sort of two hemisphere thing using the Apple projection, because Geocart has where is it it's the quasi-azimuthal. Let me just search for it. On the Apple, there it is. Okay, there's the Apple projection, and instead I just clipped that to one hemisphere, then made the other one and clipped it to that hemisphere. And then I made a joke on Twitter, and that was fun, and I got some likes, so I felt good about myself, because that's what Twitter's for. So, yeah. Chris Platt says that could be a donut. Yeah, you could do a donut projection. You could do a little two donuts side by side kind of thing. That'd be fun. So, some fun novelties. So that's Geocart. That's kind of what I wanted to reveal to you about it, and get you to think about playing around with it. And, if you want to buy it, you can throw some money Dan Streby's way. I'm sure he would appreciate it. I'm not paid to advertise this program, but I just really like it. Another thing I wanted to point out as part of our general projection talk is a fun little thing that I've been kind of building up in my mind. I'm wondering if it would be an interesting talk to give at the NACES conference, just a little short thing about some of the fascinating connections that exist between projections. And this is something I learned through Geocart and through those little projection descriptors. The ways in which projections are related to each other or derived from each other. Because a lot of projections that we see are actually secretly just other projections in disguise with certain parameters assigned to them. And that's kind of useful to me in terms of helping organize all this giant list of all these different options. Well, it turns out there's actually fewer options than you think. They're just derivatives of each other. So, for example, there is the cylindrical equal area projection. That looks, let me reset my center. Yeah, that's this thing. It's equal area. It tends to squish stuff near the top and bottom. Doesn't look real great, but it keeps all the areas correct. You can change the standard parallels of this. You can control where the distortion is worst. Right now, there are a couple of lines of latitude on opposite sides of the equator where there's no distortion, and then things get worse the farther you get from there. So I could go in here, and this is something you can do this is in ArcGIS and this is in QGIS. You can change these parameters. Hey Boyan, welcome. Now somebody who knows more about projections is going to be here. So you can critique me if I say anything wrong, but just showing off the wonders of Geocart. So I could change what these standard parallels are. I could say, shift it up to 60 degrees. And we get a more stretched appearance. What's interesting to me is that there are actually a lot of projections where somebody just changed a cylindrical equal area, the standard parallels, and then named it after themselves and said it's a new projection. So if I actually go in here, cylindrical equal area, all these are actually just the same projection with slightly different parameters. Peters, it's the same thing, just has, I don't know, where is the standard parallels? 45 degrees north. Right? Or if I change it to, Tobler, again, just slightly different. It's all the same thing. So I've been playing around with this idea of sort of, this is at 55 degrees north, 39 minutes. So I'm playing around with this idea of maybe developing a sort of hierarchical tree of the way certain projections are just related and derived from each other as a way of thinking almost taxonomically, like the way you would do in biology. You can say we have genus and family and species and such, that kind of thing. For example, if you have, I should make a new map here, and I should make it bigger. I shouldn't have deleted my old one. Is there an undo button? There is. Okay. Oh, there is an undo feature. That's good that they have that. Again, the interface in Geocart, doesn't have a lot of bells and whistles, so I wasn't sure that they would have that. Let's say I take, for example, a simple equidistant conic and shrink it down just a little bit. Right, an equidistant conic. Well, if you change that so that the standard parallels are exactly opposite each other, I gotta, or very close in this case to make it not choke, I think. Well, no, there we go. I just didn't enter it right. Now it's an equidistant cylindrical, because conic projections can be turned into cylindrical projections, and they can be turned into azimuthal projections. I can instead set this so that, not projection center, parameters, right? I can say set both standard parallels. How do I get that to interpret that with the degree symbol? I just got to type it maybe. Command Option 8. I just finally learned what the degree symbol shortcut is in the Mac keyboard. It's Command. Is it Option Shift 8? It's Option Shift 8. Right. So I've moved both standard parallels to the pole. Now it's an azimuthal equidistant. So it's kind of fun. So I might do some sort of just fun Nasus talk where I don't give anybody anything they can actually use, but an interesting hierarchy of the way some of these things are related to each other. And again, some of this was discovered by messing around in Geocart and looking at what it, these little descriptors tell you these kinds of things. So it says limiting forms of this conic projection. Well, you get a polar azimuthal equidistant if a pole is made the single standard parallel. Right? If you put it to the equator, you get equirectangular, which is also equidistant cylindric. It's that with a specific, with a different name. And so that's where I kind of discovered these things. And it's not and it's also important to note, not that these were necessarily invented as derivations of each other. In fact, the conic forms were usually figured out historically later than the cylindric and azimuthal forms, because those were easier to figure out before people started to figure they're the general case. So I've started a little diagram, and I actually did a, let me pull up that. I did a little diagram the other day about one of them, about how they're kind of derived from each other. Let me find that, because it's also on Twitter, where I just store my thoughts, apparently. Yeah, so the Winkle triple projection can be entirely sort of descended from equidistant conic. Because if you take an equidistant conic, you can get the cylindrical and the azimuthal equidistant. And the azimuthal equidistant can be sort of stretched out to create the ATOF projection, and if you mix an equidistant cylindrical and an ATOF, you get a Winkle triple. Where's the ATOF? That's just sort of a stretched out version of the azimuthal projection for a certain definition of stretched out. So, maybe ponder, maybe mess around with those things and see what you can discover. Look through all the documentation, because it's a lot of fun if you're the kind of nerd that I am. The last thing I'll mention before we leave off in the topic of fun with projections is I'll give a plug for something that maybe if you follow me on Twitter, which is probably the only way you even knew I was doing this live stream, I am putting together, maybe you've seen that I'm putting together a group of projection trading cards. This was an idea I've been toying with on and off for several months, and I finally got around to moving it forward recently. But when I was younger, I collected baseball cards, and then at various times in my life, I also played Magic the Gathering, not very seriously, but still got some of those collectible card game cards around. And I was kind of like that idea of these pieces of cardboard that we assign completely arbitrary value to, and that we like to pass around and have fun with, like, getting the one we want. So I tried to think of something cartographic for that. And so I came up with the idea of putting together trading cards for projections. So here's one that I designed for the equidistant conic projection. And each card is the same size as your standard, playing card, or your standard baseball card, or Magic the Gathering card, collectible card games. There's a standardized side called poker size that's 3.5 inches by 2.5 inches. That's pretty easy to get printed. And there are a whole host of these things that people have promised to give me. I've got a group of almost 70 people now who are doing designs and picking out projections and showing them off, so you can collect all your favorite projections. And I don't want to give away, all the ones that are going to be out there, but I'll just give you like a quick look into my folder of the current designs. I think I have 27 of them received so far, in all kinds of different styles. I didn't tell people what it should look like. You just have to show the projection and figure out what looks good. And generally people show, the graticule and such, and just some land. But there are all kinds of interesting things here. So let me shrink that down. There you go. So you got some properties about each projection, some details. There's some little icons, because there are, if you're familiar with collectible card games like Magic the Gathering, which is the most famous one probably, there are little symbols that go in the corner of the cards. And I decided for fun to come up with a set of symbols that should go in the corner of these cards. There's no reason they needed them, but I decided to encode some information, just some little icons. And I'll show you my guide to those icons. Where did I put that? Pull it up in Illustrator. So this is going to be the back side of the card, which is also a guide to what the icons mean. So we'll divide the projections into classes, and I went with the same ones that Dan Strebe does in Geocart. These 6 ones of azimuthal, cylindric, and conic, and then a few extras: pseudocylindric, lenticular, which is sort of more of a catch-all for a certain look of a projection, and then anything else. And then we track whether these have some of the really common properties that people care about, whether it's equal area or conformal or equidistant, which can mean 2 different things, but we won't talk about that. And compromise, which is kind of a judgment call. And then what are the kinds of parameters you could specify for this projection? For a conic projection, you can move those standard parallels around like I was doing a few minutes ago, or change the central meridian. So this will kind of be the guide to the icons. It'll be the back side of the card. I wasn't sure what to put on the back, so having a functional piece of information kind of helped me overcome my blank page design problem. Plus, I thought, we need to tell people what the icons mean, and if it was on a separate card, it'd be hard to make sure that everybody who had projection cards, always had an interpretation card with the legend. So printing it on the back of each one is just a better solution, I think. So that's what we're doing. Here's another one, just another preview for you. So again, this is, light gray. It's set to specify central meridian. It's a cylindric projection. And Carolyn Rose is the person who did the design. If you're just finding out about this now, I'm still open to receiving some designs. I've got a whole spreadsheet of people who are picking out certain projections. I've only received like a third of the ones that I'm going to get. I have set a somewhat arbitrary deadline of May 15th because I don't want this project to keep dragging on as more, if people kept finding it and wanting to join, I'd have to delay when things get printed, and that would kind of make sure I never got it done. So the deadline is coming up, but I also may, after doing this first set of cards, eventually open things up for a second set, because people will see these and they'll say, oh, I didn't know, I want to get in on that. Or, I wish you'd done this projection and there's not one and I want to show that projection, or something like that. So if you do want to join in, just head on over to my website, somethingaboutmaps.com, and visit my blog. And it's the first thing there. And there's a sign-up form, and which you basically just give me your email address and name, and then I'll write to you and say, here are the projections that I'd like. I'll give you some options. There's certain projections that I want covered that aren't covered right now. I'm trying to make sure we have a relatively good representation and a diverse set of what goes in. The thing that I'm still working on is how these get distributed. Again, this is kind of a whimsical idea I'm making up on the fly, but I will probably sell them at cost. I'm not gonna profit off of it. Everybody gave me these maps. They weren't paid to design them, so I'm not gonna just turn around and make a bunch of money off of it. But these things do cost money to print, and they'll cost money to ship to people. So I'll sell them at a modest cost to make up that, and maybe a tiny bit for my time packing them up, because I've spent tens of hours already managing this project, and I'm going to probably be packing up all the envelopes and sending them to people, but that won't really be a significant profit or anything like that. But I'll probably have a form where you can pre-order, and then I'll get a print, and I'll basically put together, you can probably order like packs of 15, I want to say. I thought about offering buy all of them at once, but then that kind of undercuts the concept of trading cards. And if you have them all, it eliminates the social aspect of hey, do you want to, I'll give you this card in exchange for this other card, or the excitement of finally getting one that you wanted, that kind of thing, or the mystery of, hey, I'm going to open up this pack, what am I going to find inside? There's that uncertainty, that excitement as I used to buy trading cards, baseball cards, and magic cards, and there was that thing when you open up a pack and you're looking at each one. Every time you flip that card over, there's oh, which one is it? What am I going to get? And that's really exciting. So I want to kind of, I want to give people that experience. So the company that's going to print these cards for me also sells little boxes you can tuck them in that hold up to 15 cards, I think. So I'll probably sell them in groups of 15, and I'll just pack them in. I'll give you a random assortment of 15 and mail them off to you. And you can buy multiple packs if you want to try and get multiple things. And I will probably bring them to conferences too and hand them out to people there. But we'll see where that goes. I think it's kind of a fun idea, and there's other things people could make trading cards of probably, but I've thought about the Atlas of Design. They could probably put all the maps on little cards or things like that. But this is the idea I had to just show off and get people to think about interesting and different projections. Give you one more preview there. My preview window, I got to get the aspect ratio right. There we go. Right? So you can learn a few things about your projections, and I'm hoping that somebody will come up with a game that somehow uses these cards, some set of rules. I don't know. That's something you can all think about. A couple of people I've talked to, I put the idea in their minds. Some game-oriented people, hey, this is what we're going to have. Maybe you can think of something that somehow relates to the projection or the properties or the parameters or the class. I don't know. So if you're of that kind of mindset, think about it. But in the meanwhile, keep an eye on my blog. That's when they're done and ready for people to pre-order. They'll go out there. I'm collecting all the designs. I got another 40 or 50 I'm waiting on people to send in, and I will, at that point, get a test print, see how they're looking, see if any adjustments need to be made, and then open up pre-orders to figure out how many I'm going to order from the company, and then get my order in, and I'll start sorting and packing, that kind of thing. And hopefully I'm also going to do, if you're familiar with trading cards and collectible card games, I'm also going to do some foils, where those are special prints that they have an iridescent sheen that makes the colors pop. And so I might do a special set, and when you get a pack, you might get one special version of the card there, a rarer version. It's going to be fun. This is, right now, for my actual client work, I'm not working on maps that much. I'm tidying up cartographic data, which is interesting, but it's not, I don't get to engage with cool looking maps as much right now. So this has been kind of an outlet for me. a fun way to both boost my own projection knowledge, because I've been, every time somebody sends one of these in, I got to look up what information do I need to put on this? What are the details about the projection? Then I read that stuff on Dan Streby's website, and I learn, this projection is actually, Winkle Triple is actually made from, a mathematical average of, equidistant cylindrical and such like, and the ATOF. So you learn these things through that. So that's been a fun knowledge thing, but I also get to engage with all these cool looking map designs that it both inspire me, and I get to design 2 of them myself. So that's been fun. And I didn't give people a lot of directions. And so it's been great to see all the different ways that people have interpreted this. So I've been talking at you for like 75 minutes, and I appreciate it. These look awesome. Can't wait. I can't wait for them either. I'm really excited to have a physical object that I can see and that I can hold and trade around with people. So that's been something that's kind of been keeping me going through some boring and or stressful parts of my life, has been these cool maps show up in my inbox regularly. So that's all I've got for you today. I guess what I didn't do is I didn't mention at the start that if anyone has any comments and questions, you could have said those between now and then, but I'll give you a second while I ramble on in my thank you section. If you have anything you want to add or you want to ask about, do that now. Type that in the chat. I usually say it at the beginning, but I forgot to say it, and maybe I was just talking at you in a way that didn't prompt questions. But while you ponder what you want to say, I'll give a quick thanks to my wonderful patrons at Patreon. They're people who give me money just because, and I try and repay them by doing weird stuff like this, by spending a whole bunch of time putting, one of the reasons I can spend many hours managing all the people in the projection cards and designing templates and icons and figuring out printing, right, is because the community is investing in me, so I'm trying to give back to them in these ways, and I can justify taking some time away from other stuff that clients might pay me for to do these kind of things. I do tutorials a lot more often than I do things like this, but occasionally, instead of giving you a useful tutorial about how to make something, I'll give you just a little bit of fun. So I don't see any questions coming up, and people are starting to drop off, so I guess we're all kind of done here. But thanks so much for joining me. I really appreciate you being here and spending part of your day with me to talk about a really weird, nerdy piece of software that I hope I was able to introduce you to. And if you start using Geocart, let me know. I'd be curious to know that I was able to spread the word about it, whether you use it for fun or actually make a map that starts in Geocart and ends up in another program. I might start doing that if I run into some trouble in QGIS. But with that, I think I'm going to let you go for now. So take care, everybody, and I'll see you next time, whenever that is.